I prefer, hey, guys, recording. Okay. So it's more like this. So it's the same thing, right? So we're going to do the kind of inner functions, right? So usually when I'm writing functions, right? I'm teaching even inner functions now, actually, inner functions. Sometimes you're writing a solution, right? And you realize that this solution is, let's say, let me do it with please follow me carefully. This is a concept you probably use in the coding interviews, right? So let's look at um sorry, give me a second. Reorder list. Is reorder list? Okay, so reorder list, this is a question. This is what the question is saying. The question is saying that, I hope I remember, that you're giving two linked lists. Wait, are you giving two linked lists? No, you're giving just one linked list, right? And they want you to reorder the nodes. So what happens is that, can we all see this linked list? One, two, three, four, right? Can we all see it here? One, two, three, four.
Yeah.
Yeah, okay.
Yeah.
What we want to do is that we want to create a new linked list where it's like here, there, here, there, here, there. What do I mean? The first node is going to be the first one. Then the second one becomes the last one. So take this one, take the last one. Take the second one, take the second to last. Just basically just sandwich them, right? Like take one, take five. Take two, take four. Take three, right? So like take one, take five. Take two. Can we all see it? It's easy. Just look at the diagram. It makes sense to you. Can we all see it here? Can we all see it?
Yeah.
Does everyone understand the question? They're given an input linked list, right? They're like, give us a new linked list that has the input list converted to this format, where the first node becomes the first node, but the second node in the results becomes the last node. Then, just like that, right? Does that make sense to everyone? Just take a few seconds for the question, right? Then in an interview, the interviewer gives you this question, right? Then you have no idea what to do. Look, oh, it happens. You have no idea what to do. Then the interviewer tells you this. The interviewer is like, how about we reverse the second half of the linked list? So the interviewer gave you this clue. Look, and that's what they would do. I've done an interview before where the interviewer was just like, what if we what did she then say? Forgotten. It was one of the tree traversals. She was like, what if we I forgot, I remember when we get to trees, right? This is what the interviewer's hint. They gave one hint. What if we reverse the second half of the link of the list, right? But what if we reverse that's so if you read the list into two, what if we reverse the second half? After they've given you this, I'll take a elevate person. Are you going to ask, how do we find the second half? How do we reverse? Like, no, please don't do that. We beg you, right? So once they give you this clue, they've given you two things. One, we need the second half of the linked list, and two, we need a reverse thing, right? But you have already solved reverse linked list before. It was one of the fundamental algorithms I said everybody must know. Like it has to be okay, you must know. The next one is the second half. We first saw discussed last week and K days ago that we have to be able to find the middle node. And if I find the middle node, then anything from the middle going or onward is the second half, right? So those algorithms I told you to master are fundamental. They're going to be used to solve all these many of the linked list problems you come across, right? So if I gave you one thing, but from that one thing, you know two things from it. And these two things are something you know as a tech elevate person, right? So to solve this question, I'm going to write two helper functions. One is a node to reverse a linked list, but the first is also to find the half of the linked list, right? So I'll be like this. Def, find middle node. Find middle node. Because once I have the middle, so I'm going to give you a certain linked list, then I'll find the middle node. Look how I'm going to solve this question. Then I'll not write the functional. If you're solving a coding interview, please. This is a technique people also don't know. When I'm solving an interview question, especially in an interview where there's a human being, when you're going to write helper functions, don't implement the helper functions first. Do not do that. Time will beat you if you don't take care. Instead, write the function stub like this. I'm going to find the middle node because I'll be reversing the second half. So, but for now, just write the function stub as this. Can I just write pass? I just like to use three dots so that I'm classic. Three dots is valid in Python. Then the second one is that after I found that middle node, I'll then reverse the second half of that middle node, right? So I just call reverse also. And then you see that's how you solve a coding interview. Okay, then I'm like, okay, so now what I'll do is I'll call it middle, and that'll give me the middle node, right? The middle node. So I'll get the middle node for this whole linked list. I'll call it on head. Then after that, I've got that middle node. Then I'll reverse. I think reverse also returns a node, right? The head of the new reversed list, right? Then I'll call that one maybe second. I like to call it second. Then I'll call reverse on that middle node. For now, assume this a tiny trick between these lines, but it's fine. Just call it reverse middle, right? Then after I'm done, I'm like, okay, so now I have two linked lists, right? So I have the first linked list. So I'll be like, okay, the second one is that second half. So here, the second one is going to be, let's say, 3 and 4, right? 3 and 4. Then the first half is going to be 1 and 2, right? But I want to dissociate them, right? Because if I don't disconnect them, so I want to dissociate it basically. I'll be like, I'm going to dissociate them, right? So just think of that in your mind. So the first, so assume it's been dissociated. So the first is the head, then the second is the second half, right? Then I'll now do the actual linking, right? That's linking thing, where it's like you look through both of them, while first and second, then do the rest of the logic, right? Like, take the first one, take this, so like basically like what I mean is like result is equal to like, take the first one will always be the first one, right? Result is equal to first, right? Then you just do your linking here, right? That's the rest of the logic you can work on later. But after you have done implementing the rest of the logic, I'm showing how you do a coding interview. Then I'm implementing this kind of logic. Then now you come to fill in those helper functions. Can we all see that here? We fill in these helper functions. Now, this way of identifying what we call inner functions. You know what it's called inner functions is this. You realize that I just created these functions inside the main function. It is possible in Python and many programming languages. You can write a function inside other functions. There are reasons why we like to do this, right? For this particular question, the benefits are not obvious. But for a question where, like, we see it a lot in trees, where these inner functions need to access variables that are defined in the main function, it's good to nest your functions as this. That's one reason why we use these inner functions. But sometimes these inner functions you are using, right, they want to access variables outside of them, right? We call them non-local variables. They're not local to this function, right? Other programming languages, like Java, gives you, sometimes you see something like, you have a variable here like called maybe you can create as a class field here. But usually in coding interface, you don't have classes, right? So that's one reason why we use inner functions. When you access variables outside, you see it a lot when you get to trees, honestly. Like you see it very much. Many of the three questions, this notion of inner function and non-local variables save you a ton. They save you a lot of time. They save you a lot of time, trust me, right? The alternative is to you could have written these functions independently, right? And called them like at the same level as this guy, right? But usually when you nest them, it's much easier. It's much easier. That is number one. When you access variables outside of them. Number two, also, sometimes you don't want to pass. Let's assume you're doing two sum, right? Where there's a target variable, right? Which is the same across everything. And you don't want to pass target to the function call again, right? You don't want to pass that same variable across. Can use inner function. So here, if I write target here, it will actually work because to first check, is target in this function? No, it's not defined here. Then to step out to its outer function, like, oh, target is in the outer function, then it can access it. So that's one reason why we also use inner functions. So I feel like those two things are usually the main reasons why we use inner functions. When we'll be accessing a variable that is non-local to this guy, so maybe the variable was defined, let's say you have a variable called track or scene. Usually it's seen, right? In graph and tree algorithms, our result scene is here. There's a question I think Philippa posted to the group chat about flipping trees. And if you use this, right, it makes your life more easier. Like right no local, like scene here. That means that if access scene here, like scene dot, like if something in scene, like you're like if this in scene, right? It should be like, oh, scene is not here. It's not local to this function. It's actually here. If you're not familiar with this, don't worry. Once we do the trick questions, you'll be very familiar with this. I hope you probably saw it in there too. Okay. So that's inner functions. I was going to watch inner functions of even let's come on to a reverse linked list. So a reverse linked list, we're going to do this a similar thing, right? Like reverse list here. I'm going to define a function here. I'm going to be a recursive function. I'm going to call it solve, right? And I'm going to pass just a node to it, a linked list to it, right? Solve. Then I'm going to assume I'm going to divide my linked list. Linked list is an iterable, right? I'm going to divide it into two parts. The first part is the head, right? The second part is head dot next. It's the same as what you did left and right, right? Left is this, right is this, right? I'm going to divide it into two parts, right? I'm going to assume the function works, right? If I reverse the just a linked list containing one node, like, you know, you know, yeah, it's just going to be like, but I'm going to just take out the node, right? Head is just still a point. I'm going to take out just the node. So just pay attention. Just follow me. I'm going to make it much clearer, much cleaner. Okay. Head of our. Then so I can just call reverse list. This function is so long though. Reverse, sorry. The function is so long. let's put everything aside. Let's even ignore this so that we just use that function like once and for all. Please follow me. It's very easy. It's very easy. Right. So I'll write base case later. I'm just focusing on the recursive case. So left val is if I'm just going to reverse just the first part, right? Like reverse list. But the thing is so long. Let's just write left. Then I'm going to reverse the second part. Let's just call right val. Just reverse it, right? Reverse, you know, right. Now the thing now becomes if we're resuming the function works. So I'm believing that I have reversed, like I've reversed I've reversed like this whole thing, right? Can you see I've reversed this whole thing? Like this whole thing you see here, this guy you see here. 2, 3, 4, 5. I'm assuming that believe that I've reversed this whole guy here, right? If I reverse this whole guy here, they're going to return to me 5 as the what do you call it? Um 5 as the head node, right? 5 as the previous node. Does that make sense to everyone? Like if I reverse this, they're going to return to me 5 as a head node. If I reverse 2, 3, 4, 5. Too much silence.
Yeah.
Let me just look at this. Let me just use the solution to explain to you. I feel like when people see the code, the reason through it probably make more sense to them. I wrote the recursive. I really believe I wrote the recursive solution somewhere. Yes, it is this. But I want to convert it to. I'm convert it to Python for you. I think I wrote it in Python. I wrote this like a couple of months ago. It was so pretty. No, I really want. I think I wrote it in Python too. No, I didn't. Let's see if somebody has it here. The recursive. Maybe if you look at this one to make sense to you. Yeah, man. Okay. Please don't worry. This one is not a must know, by the way. If you go and sit down, it will probably make more sense to you. But I saw this algorithm, I was like, it's so pretty, so beautiful. And people don't write good code. Look at this guy's code. It's not nice, but I do with it. Yeah. Um, yeah, it's like it's not the cleanest code. But please bear with me. I want to clean up this code, right? So this like if just like a list, if the list is 1 length or 0 length, you just return the list itself, right? So we're just saying if not head or not head dot next, right? That's like if the list, if it's just one, like if it's just one node or none, you can just return that one, right? That's what it's saying here. Then if I flip it, so yeah, I reverse the second part, right? That's right. If you flip the second part, we get the second one, right? So this is what we used to call right val, right? Like if this, like I've reversed the second part. Do you all see it? I've reversed the second part. Does that make sense? Like this is just like me with like I've reversed 2, 3, 4, 5. Does that make sense to everyone?
Yeah. Yeah.
Yes.
Okay. Then usually you can actually bring this before, but it's fine. Then this head dot next, right? This head dot next, this is head when it came in, it's 1. Head dot next is what? 2, right? Usually I like to write this one because it's fine. It's also like so this is head dot next, right? That is 2 here. So you take that 2. Now you know that at the end of your reversal, look, at the end of the reversal, right? After you reverse this, that's guy here, that 2 here, its next is going to be that original head. Can we all see it here? Look at the output. This is what you got from after the reversal. We can see that at the end of the linked list, that end guy here, that 2 guy here, right? Its next is going to be the first one, right? And that is the combination step you're doing here. That so if I'm supposed to rewrite that, just be like second node is going to be head dot next. Then I'll reverse. Look at here. Then I'll reverse the second part of the linked list. I'll do the reversal. I'm just going to do the combination step. The combination step is second dot next, right? Linked list are pointers. Don't forget. It's going to be the head I have here. That's what I have here. Then now I can dissociate heads of next because now once next should be none, right? Should be none. That's basically what I'm doing here, right? And like tada, you are done basically. And after you just return a new head, and that's basically the whole solution. It's very intuitive. The only thing is just have to make sure you store these 2 guy, right? Because at the end, if you look at the end, that's this part is reversed. That 2's guy, its next should be 1, right? And that's the whole thing. So store the 2 guy, reverse the rest of the linked list. After that, just do the connection, right? And you're done. And this is simply reverse linked list. It's much cleaner, and for me, much better than return right val. Right? And you're done. That's the whole reverse linked list algorithm. And it's like very intuitive too. Does that make sense to anyone at all? Or it was just me? Yeah, it's pretty. It's a very nice algorithm. Like, yeah, it's very clean, very
Yeah.
it works, right? Reverse the second half, store the pointer to the second guy, point its thing, and you're done. and it just works, right? Okay, are we good to go? To trees.
Yes.
Yeah, please understand this algorithm is pretty. Many of these questions can just have it like this, and it's cleaner. Okay. Okay, beloved trees. Okay, stop screen recording, restart, and let's